বাকিরা কি আসবে না আসবে না?
আসবে আসবে, তুমি চাইলে স্টার্ট করে দাও।
4:10 অবধি দেখি।
ঠিক আছে।
Can I start?
Yes, yes, no problem.
So first, any doubts regarding yesterday class?
No, sir.
No, sir.
Can any one of you please make a synopsis of yesterday class? What we learned yesterday? Any one of you? Anyone, please unmute and just make a synopsis of yesterday's class. I think 34 is here. 33 is here. Any one of these 33 students? Please make a synopsis of yesterday's class. What we learned yesterday? I think Binayak is here. Binayak, please unmute. And say something about yesterday's class.
Yes, sir.
Make a synopsis of yesterday's class. What we learned yesterday?
Sir, we learned about statistical inference, type 1, type 2 error, hypothesis testing. Sir, I'm not able to comprehend the whole thing together.
Please carry on.
Sir, can someone take over from here? It will be better.
It will be better. Polomi Mondol. Please
Sir,
unmute.
we learned in yesterday's class that what is variable. There are four types of variable like ratio, interval, nominal and ordinal type. And then we are come over to population and sample. What is population? What is sample? Then we are going to look at the that the our goal is which distribution of our data follows. Then we go through with the distributions like Bernoulli, Poissons, and normal distributions. Then we are go through with that there is if our it is a large number of samples like in greater than 30, then it all go to the normal distribution. And then what is parametric and non-parametric changes.
Thank you,
Then
Polomi. Stop here. Stop here. Shamrat is here. Shamrat, please continue from here.
Sir, I got disconnected in between. Sorry for that. I just missed the first part of the class.
Not yet. They just started the class. Polomi just covered the first part up to parametric, non-parametric. Then the part that taught yesterday, you just make a synopsis of that.
Yes, sir. Can I have 1 minute, sir?
Yeah.
Yes. Yes, sir. Can I continue?
Yes, Shamrat, yes.
Yes. So Ptolemy said till non-parametric test and normal distributions. So given that we have we have our samples and we know that sample follows something, say normal distribution. So when the sample follows normality, we can do some testing, likely the hypothesis testing, and we have following tests. Let's say the t test, the z test, and other chi-square test. So then we discussed yesterday that what is level of significance. So level of significance implies that how much rejection area, how much error, that the concept of type 1 and type 2 errors, how much error we allow in our conclusion. And then we discuss about the two types of errors in detail. And then we discuss about the CLT, what is central limit theorem. Following that, we discussed the p-value, which is a relatively useful measure nowadays. No longer significance is being used; the p-value used. So p-value's definition goes like this: it is the smallest value of alpha for which null hypothesis is rejected. And then we introduce the concept of QQ plot, which says how to check normality. Normality checking is essential because if we check normality, then and then only we can go for the test, the hypothesis testing, which I mentioned. And following that, we have various kinds of tests of normality. Like one is the QQ plot, which I just told. And there also the p-value decision rule remains the same, p-value greater than 0.05. We do not reject the null hypothesis, which is the sample data is not significant, is not normally distributed. I mean, it is normally distributed. The null hypothesis was for the p-value test. And once we check for normality, like I mentioned, we can do the hypothesis test. And then we did the test of mean. Sir, am I audible?
Yes, yes, absolutely. Very
Yes.
good. Fine.
Yes, and then we discussed the concept of hypothesis testing. The two types of tests which we did was the test of mean initially, and test of mean, we had two cases. One was the sigma known and the other was the sigma unknown case. So we saw that in the sigma known case, we do the z test or the z test, and the statistic follows x bar minus mu by sigma by root n. Following, we have a decision rule there also that can be converted again to the p-value test. And also similarly for sigma unknown case, we have a similar kind of statistic. Sigma is being replaced by the unbiased estimate, which is the sample variance with the denominator n minus 1. And then sir introduced the concept of ANOVA. So what the difference between ANOVA and hypothesis testing is, they are pretty much similar, but in ANOVA we do multiple mean testing. Like in t-test, we are concerned with, say, a single population, we check for their means. We collect a sample and we check with the population mean whether they are same or not. But in ANOVA, what we do, we use it for more than two populations. For two populations, we can use the t-test, but for more than two populations, for comparing the mean, say mu1 equals mu2 equals to mu3 and so on, we have to use the ANOVA test. So ANOVA test basically summarizes in this way. We have something called the total sum of squares. Maybe I'm wrong here. Total
Total sum square equal to sum square between plus sum square within or error.
Thank you, sir. And then following we have, if we divided by the degrees of freedom, we get something, the MSB.
Yeah,
That is the mean sum of squares. And following we do the we get the F statistic. And F statistic, the decision rule remains the same. So higher F statistic implies that we don't we reject the null hypothesis, and that means our null hypothesis was the mean was equal. So higher F value will give us that the means aren't equal, and that is basically the summary of yesterday's class. Thank you.
Thank you, Samrat. Very good. Very
Thank you.
quick synopsis of the yesterday's class. And now I think you can teach your friends like this way. Very good. So I think all of you now aware of the yesterday's class. Samrat Paulomi and Binayak rightly summarize the entire thing. And when they summarize, they mistakenly use some term, but remember that terms, entire statistics is based on hypothesis testing. Whatever you done, t-test, ANOVA, chi-square, regression, in every case there is a hypothesis testing. In every case there is a hypothesis, and we try to test that hypothesis. And what are the procedure? Procedure is, we are assuming our sample observation is following normality. This is the assumption, and that's why we have to check this. If our sample data does not follow normality, don't worry, there is other tests, that is non-parametric test. So in reality it may happen our data does not follow normality. So in that case we cannot do the parametric test, we have to go for non-parametric test. You just see, I am starting from the slide. You all go through the slide, I know. What is happening? This one. Just a minute. What's this? So this is a summary of hypothesis test about mean. Only for mean. So first is how many samples? First is one sample. If it is one sample and population variance is known or unknown. If it is known, then one sample Z test or what is known as Fisher Z. If sigma is not known, then we have to use the one sample t-test. Now it comes from two sample. Hypothesis about the population mean. So for two sample, first check it is pair or not. If it is pair, then go for pair t-test. If normality is there. If normality is not there, then the just like the pair t-test, the non-parametric test is Wilkinson sign rank test. This is a non-parametric test. When we use this, when our observation set or our sample data does not follow normality. In that case, we use Wilkinson sign rank test. Now, if the samples, two samples are not paired, then go for independent sample t-test. If normality is there. So if normality is there, then go for two sample t-test. If normality is not there, then go for Mann-Whitley test. So if normality is there, go for two sample t-test. If not, go for Mann-Whitley U statistics. This is a non-parametric test. Now comes two or more sample. So first one is one sample, second is two sample, third is two or more sample. Two or more sample, number of variables, that is samples, correspond to the different levels of variable. If it is one, it is sample is two, but dependent variable is one. Then it is one-way ANOVA if the data follows normality. If the data follows normality. But if data doesn't follow normality, then we go for Puskal-Wallis test. That is a non-parametric ANOVA. Puskal-Wallis test. And if it is two variable, that is group is two or group is more than two, and dependent variable also more than one. So in that case, we go for 2A ANOVA if the data follows normality. If not, then we go for Friedman test or randomized block design. This is the entire statistical part. I am not going in detail of this part, two variable parts. I am considering only for one variable. So today I will show you how you perform independent sample t-test, this one, pair t-test, and one-way ANOVA with the help of R. So when it is clear now, when we use this two sample t-test, when we use pair sample t-test, when we use one-way ANOVA. So basically, we are concerned about to test the population mean, hypothesis about the population mean. And first taxis is the population variance is known or not known. So if it is unknown, then we go for this way, pair sample T or independent sample T. Now consider this example. Read this example. So in this case, what happened? The company actually willing to know, is there any difference between blood pressure levels of two groups? So one group with old drug and one group with new drug. So two group is there. And clearly this two group is different group. They are independent group. Clear? So when it is a two group is independent, we don't know the population variance, but we test the difference between the blood pressure levels of the two groups. That means we are concerning with the average. Is the average of the two groups are same or not? So if it is same, that means new drug and old drug have same effect. If it is not same, then there is a difference between old drug and new drug. So in real life, when we formulate our hypothesis, so on the basis of the hypothesis, this is the null hypothesis. There is no difference between the blood pressures levels of two groups. That means here the null hypothesis is mu1 equal to mu2. This is the population mean. Against the alternative, mu1 not equal to mu2. Against the alternative, mu1 not equal to mu2. Or one can say the null hypothesis is mu1 minus mu2 equal to 0. Against the alternative, mu1 minus mu2 not equal to 0. I already send you the data for this test. So for t-test, we use the data set named SM_2_09, I think. I send you the data. SM_2_09. And this file is a SAP file. This is a SPSS file. So how to import this file? First, how to import this file? So when a foreign file is there, it may be stata file, it may be that is extension .dat, it may be SAP file, it may be Excel file, it may be CSV file. How we import that file? So one can write this type of codes to import this file, or simply here is the option import dataset. Here is the option import dataset. So import dataset. If you click here, so these are the available option. You can directly import, use this menu tab. So from it, you can export from Excel, you can export from SPSS, you can export from SAS, from Stata, from TXT file. You can export anything. So when we, here we try to export the SPSS file. There is a SAP extension. So just click on from SPSS. From SPSS. So this window opens. So you just browse your file. The file name is SPSS SM_2_09. This is a file. Just open this and see, automatically see the code preview is here. This is the code. Here. So if you copy this code and paste in our script and run this, you can automatically import your data, or simply you just click on import. Click on import. So automatically that this is the code and this is your data. So there are two group, and this is the second group, and this is the mean blood pressure. This is for first group. This is the old drug user, and one is for second group, that is the new drug user. And what is our null hypothesis? Null hypothesis is we are testing mu1 equal to mu2 against the alternative mu1 not equal to mu2, or mu1 minus mu2 equal to 0 against the alternative mu1 minus mu2 not equal to 0. So how we write the code for t-test? First task is we have to attach the file. So write this line.
Sir, can you repeat from the first means from how to import dataset and all, because there was an issue in my network, so I couldn't
Import
hear.
dataset. Here you click on import dataset.
Okay.
Then from SPSS.
Yes.
Why? Because we are importing here the SAP file is the SPSS file. Click on this, then browse your data. Clear? So just click on this.
Okay.
You see the preview, and here is the code, and then input.
Okay. Okay.
And what is the first task? First task is attach this file. First we attach this file. Second, we want to see the structure of this. This is the structure. Group is once again number, blood pressure is a number. So group is here representing the number, right? Blood pressure is also a number. What are the names of the variable in the data set? Names. Here two variable, one is group, one is blood pressure. But as we know, for t-test, for independent sample t-test, there must be two groups, but in data, the groups are not defined. This is only, this is the group is here numeric variable. Only 1, 1, 1, 1, 2, 2, 2. So we have to first define the group. First we have to define the group first. So we write this line, group equal to S factor group. So we define this as S factor group. So here we write, it will change. We run this. So group become a factor variable. That is, two factors is there, 1 and 2. Now what are the assumption for t-test? As we know, sorry, what are the assumption? Two assumption. One is normality, another is equal population variance. So for normality test, what are the criteria? We can use the Komlov test or Sarpio test. And for equal variance, we have to use the Levens test. So how we perform in R? For Sarpio test, the normality test. Sarpio test is, this is the code. Command is this, Sarpio dot test, and within bracket name the variable. So if we click on Sapio test, Sapio dot test blood pressure and run this, you see, this is the output. This is the output, right? So what is the p-value? P-value is more than 0.05. What is the rule of thumb? If p-value is less than 0.05, we do not reject null. So here we do not reject null. What is the null for the test? Sample observation is following normal distribution. So in this particular case, our observation set is following normal distribution. So we can perform the parametric test or we can perform the t-test. Clear? We can perform the t-test. Now we want to test the homogeneity. So for this, we have to call this library car. The name of the library is car. So first call this library car. And then the command is Levin test. Levin T is uppercase.
Sir, it is showing an error when I'm trying to call the library car.
What is the error?
It is saying that there is no package called car.
So you just install the library car using install package.
Install package. And then the package name is car.
Package name is car. Obviously the library name and the package name is same.
Okay, sir. Thank you.
So all of you able to call the library car? All of you able to?
No, sir, face the same error.
No, sir, it's saying that it's unable to install packages.
Sir, it is downloading. It is taking some time.
Yeah. You just install packages car and then call the library car.
Sir, now it is showing some other error after installing the package card. It is saying
What is
that
the?
loading required package card data.
Oh, don't worry.
Okay.
You call your library, it automatically comes.
Sir, it is saying a version of this package for your version of R might be available elsewhere. See the ideas at http scran.r project slash doc slash manuals like that.
You can share.
Um,
You can
and,
share. Please share.
can I show it in my back camera?
In your back camera, is it visible? Then you show.
I don't know. Wait.
You can try. You try just.
Can you see?
Just a minute. It is not visible. If you call library car, is there any showing error?
Yes, sir. It is saying that
What is
there
the
is no
error?
package called car.
Are you install the package car?
No, when I'm installing, it is saying that unable to access index for repository and the version.
Same problem you faced yesterday, day after yesterday.
Which problem?
The same problem you faced. So you have to install in from art
R.
depository. It is from opening art.
Oh, okay, okay.
So remaining all other.
Sir is doing it.
So all of you are able to call the library car.
Yes, sir.
Yes, sir.
Yes, sir.
Vinayak Bhaskar, then Paulomi. Remaining all others. What about Anushka, Pritha, Songita, Danish, Pitan? All of you?
স্যার এখানে
Yes,
কার্ডটা
sir.
ইনস্টল করার পর বলছে যে কার্ডটা নামাতে হবে।
What Anushka?
স্যার কার্ডটা ইনস্টল করলাম কিন্তু তারপর বলছে যে কার ডেটা নামাতে হবে, ইট ইজ রিকোয়ার্ড টু
No, no,
ইনস্টল
no,
কার্ড।
not worry. You just call the library car. It's
হ্যাঁ
fine.
স্যার ওটা করেছি, তারপরে ওই যখন লাইব্রেরিটা করলাম তারপর বলছে এরর দিয়ে ওটা দেখাচ্ছে।
No, that is not error. It's a warning message.
আচ্ছা
So what about all remaining others? What about Suranjana, Rajarshi, Manisha?
Sir, in my laptop, it's showing that the object R package is not available.
Object?
R not found.
Object R is not found.
Yes, sir. When I'm calling the packages,
Can you
sorry,
can you
installing the
share your screen?
packages.
Can you share your screen?
1 minute, sir. Sir, can you see my screen now?
Yes.
Yes, sir. This is showing.
You are not installing the package properly. You just first install the packages.
Card should be in inverted quotes in line number 11.
You just click on tools. You just click on tools. Yeah. Then install package. Right car. Just install.
Yes, sir. It's downloading now.
Always try to install like this, in this way, using tools.
Okay, sir.
Otherwise, you write there is a syntax error or something that's why there is a problem. And you just call up the console. You just call up the console. So
Sir,
when
I
the
got
please scroll down this console.
What, sir?
Yeah. No, you just move to the upper direction. You just move your console to the upper direction. Please. You just see the code in console. Scroll up. What is the code? Let's see. Install packages within
Okay,
double inverted
inverted.
car. Right?
Okay, sir.
So you are writing the code wrong. So if there is a problem, you just help the menu. Take the help of the menu option.
Okay, sir.
I think Shamrat rightly pointed out in line number 11, you don't use the double inverted code. So now it is clear.
Yes, sir. Yes,
This is
sir.
the right
Thank you,
code.
sir. Yes, sir.
Clear? So just call library car.
Okay, sir.
So all of you now able to install the library car.
Yes, sir.
Yes, sir.
Actually, the problem is only 2 or 3 of you are actually responding. All are not willing to respond. So just write this 11 test within bracket. This is the dependent variable. Blood pressures and group here. Group is a factor variable. So if we run this, so this is the output. And what is this? This p-value is more than 0.05. Once again, we are assuming that here the rule is, here the conclusion is, we do not reject the null. That means homogeneity is there. So we can perform student t-test. So step number 1.
Can you please explain this part once again?
Yeah, I am
The
explaining.
11 test.
I am explaining. So step number 1, first we have to check is our data following normality or not. So we check with the help of Saprio test, and Saprio test assure us that our data is following normality. Then we can able to run parametric t-test to test the mean. Next step is the variances of two groups are equal or not. So we are now eager to test the equality of variances or homogeneity. In that case, we are using the Levin's test using the package car. So you only can run this Levin test using the package car. So in that case, you have to remember the package name. The homogeneity of variances, the test is here. We are used here Levin's test, and the Levin test is possible with the help of this library car. Otherwise, if you don't call this library and you try to run this particular line number 22, you cannot able to run this. So before running this particular code, you have to install the library car. And when you run this is the output. So what is the p-value? Probability greater than f. That is, this is the p-value. P-value is 0.44. It is greater than 0.05. As we know, what is rule of thumb? If it is more than 0.05, we do not reject null. So if we do not reject null, means in our test of equality of variances, what is the null hypothesis? Sigma 1 equal to sigma 2. Alternative, sigma 1 not equal to sigma 2. So now here, since p-value is more than 0.05, we do not reject null, means sigma 1 equal to sigma 2. So if variances are equal in between two groups. Clear to all of you?
Yes, sir.
Yes, sir.
So next we can able to run the t-test. And what do we write here? That function is here t dot test. This is the function. Function is t dot test. This is the dependent variable. Then tilde. Then the variable is the group variable name or the categorical variable name. Here it is small group. Right? Here writing variance equal is true. Why? Because the level state from this test we can clearly say that variance equal is true. If we run this, this is the result for t test. Simply concentrate on p value. Don't look anything. Only p value. What is p value? It is 0.09. So it is more than 0.05. What is the conclusion? What is the inference? Do not reject null. If p value is more than 0.05, do not reject null. So if do not reject null means mu1 equal to mu2. So old drug and new drug have same impact. So the impact of both the drugs remains same. And what is the group mean? This is the first group mean 90.8 and this is the group mean for 81.2. Here also the alternative hypothesis is written. True difference is mean is not equal to 0. But we are not accepting the alternative hypothesis. Here we do not reject the null. That means mu1 equal to mu2. So in this case, old drug and new drug have same impact. There is no difference. Clear up to this part?
Yes, sir.
Yes, sir.
Yes, sir.
This is the QQ plot to check the normality. So see, this is the theoretical line and this is the estimated line, estimated quantile. So more or less all are on the line and that we test on the basis of the Sapio test. This is the value, this one. So with the help of diagram, we can infer about the normality and we can sanguine with the help of this particular p-value of this Sapio test. Yesterday I was given the concept of the QQ plot, but I am not shown in how to create QQ plot in R. So this is the code. Simple QQ norm, the variable name, and if you write the QQ line, then automatically this is the QQ line. And we are using here the simple base function, base package plot, not ggplot or other packages. Right? So up to this it is clear. I think t-test is clear to all of you.
Yes, sir.
So Binayak, you are from which college?
Sir, I am from Vijayagor Jyotish Rai College.
Oh, so are you present in the workshop that I was taken in 2019? You remember
No, sir,
that?
I was not there because I had some other subject. I had rural development. I did not have the one you.
I was there in 2019, just before the corona period.
Yes, sir. We had two workshops on different DSCs actually. One was done by you and the other one was done by some other teacher. So I was present.
Pinakida, otherwise done by the Pinakida.
Yes,
Rural
sir. Yes,
development. I know
yes,
that.
sir. And Shantanu, sir.
Yeah. So
I was present in that.
Polomi, you are from which college?
So Vidyasagar College for Women.
Women. Samrat, you are from which college?
Sir, Bhawanipur College.
Bhawanipur Education Society.
Yes, sir. Elgin Road.
Elgin Road. So maximum are from Bethune. So where you are? You are not responding?
স্যার আমি বেথুন অনুষ্কা
Anushka, you are from Bethune. So all other remaining others from Bethune? They are playing a role of outlier here. Or silently learning. And what about the heritage?
I'm from Heritage College.
I know, but why you are not responding?
So I respond whenever I can.
So only you, remaining others?
So one of my other friend, Kathy Choksi, is also here, and she
Yes, sir.
is always responding, I believe. The other two
I
have
am.
just had some.
So if you not respond, then in online mode it is very tremendous job to take a class. So it is not possible to look your faces. So without looking your face, I am try to deliver something. And if you not cooperate with me, then it is very difficult to teach. Right? So please cooperate. Please say something. The yes, no, or whatever we have the doubt. So otherwise, it is very much difficult to teach like this type of particular programming language on online mode. That's why I'm asking you. Don't hesitate.
So actually, whenever I'm having a problem, I'm asking you, and more or less, I think I've been responding only, and I will try to respond more and further as well.
So next we go for the next one. So listen, read this particular case.
Sorry to interrupt, but can you just once show the code for t-test once again?
I will definitely show you.
Yes, thank you.
But first you read this particular one.
And sir, please explain the normal QQ plot also once again.
Yes. Before that, you just go through this particular case. So which test is applicable for this particular case?
So the test of mean.
Test of mean. Fine. Population variance is known. Population variance is known or unknown?
Sir, if we collect data for, known. So the first day's data will be recorded.
My question is population variance is known?
Yes, sir.
Known. Population
Yes, sir.
variance is known here.
Sir, we are recording the observations for 15 workers for the first day. So we have the population with us.
Which one is population? This 15 workers is population.
So population is all the workers.
All
Sir,
population is
that
all
is-
workers.
Sir, that is not mentioned. So I thought 15 is the population size.
No.
Oh, got it, sir. Yes, sir.
That is not mentioned.
That is a
Rightly
sample.
pointed out. Why not mention? Because this is the sample.
Yes, sir.
Check
Yes,
all
sir.
15 workers, but all other workers is there. So we don't know the population variable.
Okay, there are other workers. Yes, sir. Fine.
So what is the test? When population variance is unknown, we are trying to test the mean. That means we are here also, we are applying the t-test.
Yes, sir.
Yes, sir.
Now, what is the difference with the previous case? In previous case, the individuals in two samples are different. But here, the individuals is same. So 15 workers before and after the training. So some particular unit produced by them before the training and after the training, the record collected before the training and after the training. So here the individuals are same. So here we use the pair t-test. So when we use the independent t-test, when the individuals or the group members are different, there is a independent. But here the two individuals are same, but the situation is here pre or post or after and before. So before training and after training. And what is the null hypothesis? There is no change in productivity. That means training have no impact. And what is the alternative hypothesis? Alternative is the mean must be different. So null hypothesis is mu1 not equal to mu2. And what is the alternative hypothesis? Alternative hypothesis is mu1 not equal to mu2. Clear? So now here we import the data set, that is the Excel data file. I give you the Excel data file. I think the name of the file is sm_pt. So from Excel, then browse the similar way. sm_pt XLS. Click on open and see the code. This is the code. If you're willing, you just copy this and paste this in R script, or otherwise simply import this. Clear? So this is the data. This is the 15 observations before and 15 observations after. So when you willing to use the pair t-test, so you have to put data in this manner. In first column, the observations or the details of the before the training or before the activity, and after, this is the after activity outcome, right? Now what is the next step? What is the next step? The next step is, first we try to know the names, then the structure, and here both are numeric. Next steps is how we find out the normality. So for normality, when independent case, we just select the dependent variable, only the dependent variable. See, only the dependent variable. Shapley or Dorsey and the name of the dependent variable. But here in this case, one is for before and one is for after. So to find or test the normality for this pair T case, we first find out the difference of both these, right? What is difference? Difference is before minus after. Difference is before minus after. We are not attaching, right? See the error? Don't worry. Object before not found. Why? Because we are not using this command attach. So first you attach, forgotten, then find the difference. Then use QQ noun difference and into line difference. If we try to run this QQ norm difference, see, this is the points. These are the sample quantiles and theoretical quantiles. Fit the line. See, more or less on the line. So the rule is after watching the QQ plot, if this line representing the theoretical quantiles, if the sample quantiles converge with this line, so there is a chance of normality in your data. If there is a huge divergence, then your data may not be follows the normality. And you can next, this is the interpretation. This interpretation is on the graphical visualization. Now we test this, is our data following normal or not, with the help of Shapiro test. If we click this, see the p-value once again, 0.6428. This is the p-value. Clear? This is more than 0.05. What is rule? Do not reject null, implied data following normality. So you can go for t-test, right? So once again, the function is t.test. So when we use the initial case for t.test, we write this like this: blood pressure tilde group. That is, group wise blood pressure varies or not, and variance equal is 2. When we try to use the pair t-test, in that case we write here before after, and paired is 2. Paired is 2. And click this. And run PT test. And see, this is the p-value, 0.007. So it is less than 0.05. What is the answer? We reject null. We reject null. That means mu1 not equal to mu2. That means training have some impact. And what is the mean difference? This is the mean difference, 8.8. And this is the 95% confidence interval. Here. So how we perform t-test and pair t-test using this R. Clear to all of you?
Sir, can
Yes,
you
sir.
explain the t-test part once again after the Shapiro test?
Line number 47. Now line number 50. Clear?
Yes, sir. Yes, sir. Got it.
It is clear?
Yes, sir. It's clear.
Sir, we are not using the normality test because the population variance is unknown over here.
Repeat. Repeat once more. Please. Please repeat once more what you asked. I cannot properly listening.
Sir, can you hear me?
Yeah, Minak, please.
Sir, I am saying, are we not using the normality test over here because the population variance is unknown?
You make little bit of confusion. There is no relation with population variance and normality. Before the population variance test, we are checking the normality. Clear? And when we check the population variance, when there are two groups, two independent groups, that's why the variance, we check the population variance. But in case of pair T, the group is same, group members are same, not there is no two independent groups. And the statistics, basically the statistics is used here in p-test in terms of difference. So the only single series. Basically pair t-test is nothing but the one sample t-test. We are using this in terms of difference. D is everything. In pair, if you go to the Gungupta book, the formula is given. D bar minus standard error of D bar. Right? So when you're talking about the independent t-test, there the question of variance, equality of variance comes. Why? Because two groups are there. When you're talking about the ANOVA, then equality of variance come. But in case of pair t-test, equality of variance is no longer required. But normality is required. Normality is totally
Okay,
other
sir.
thing,
Thank you,
and
sir.
variability is totally other thing. Normality of our data, that is our data is following normality, means it is drawn from normal population. But when there is two groups, then we check is the variance of the two groups is the same or not. If it is same, then student T. If it is not same, then if we write here it is not same, variance equal is false, then it automatically gives us the result of Welch T. Clear, Binayak? It is clear to you, Binayak?
Sir, actually, I lost the connection in the middle. My Wi-Fi is not working properly today, so I could not hear the end part that you said.
Right now, or
Right now, sir, right now, the end part that you were saying, I lost the connection.
I just said that if you don't confuse with normality and homogeneity, normality is totally another thing, and homogeneity is another thing. Normality means we try to check is our sample observation following normality or not. That means it is drawn from normal population or not. And homogeneity means for two groups their variance is equal or not. So homogeneity means the variances of two groups is equal or not. But normality means our data follows the normal distribution or not. If our data follows normality, then we check for homogeneity. But if our data does not follow normality, then it cannot be possible to check the homogeneity. Then we have to go for non-parametric test.
Yes, sir, I understood. Thank you.
Sir, I have a question.
Yes.
Sir, can you explain once again how the QQ plot is being interpreted?
This line is the theoretical quantile line. Theoretically, this is the line. And this is your sample value. If sample value coincide with the theoretical quantile, that implies it is the normal. Your data following normal. If it not coincide with this line, that implies it is not a normal distribution.
Okay, sir. Okay.
You see this? I'll show you this diagram yesterday.
Yes, sir.
Now we move to one-way ANOVA. So when we already know when we use one-way ANOVA when there is more than two samples, and we try to test the mean. Here we use the data set, the inbuilt art data set. We just write this command: attach insect sprays. Attach insect sprays. INSECT, S is in caps. Clearly visible, I think. If you run this, then click on data. Here, then see this view data first. This is the count, and this is the categories: A, B, C, D, E, and F. 6 categories is there. And for every category, 12 observation is there. 6 into 12, 72 total observations. This is the data set. It is clear up to this part.
Yes, sir.
Yes.
Now see the
Yes, sir.
structure. Clear? This count is number, this factor, and the data is in data frame. Right?
Yes, sir.
Now use this particular function t apply to see the count wise, spray wise, mean. To run this is the table. So for category A, this is the mean. Category B, this is the mean. Category C, this is the mean. Category D, this is the mean. Category E, this is the mean. Category F, this is the mean. And what is the variance? T apply, count, spray, and var. And then length. All have 12. If you don't view the data on the basis of this descriptive statistics, you can easily know what is the average, what is the variance, and how much, what is the length of each category. Clear? Now we use box plot. This is a box plot. See, this is the box plot. So these two, clearly these three are different from these three. And these are the outliers. Since this is a small sample, we are not right now bothering with the outliers. So this diagram clearly represents there is a difference. And to statistically test that, we use here ANOVA. Here the function is AOV, and object name I give here ANOVA output, AOV.out. Here AOV. This is our dependent variable, and this spray is the categorical variable. Count is our dependent variable, spray is our categorical variable. Here we are not using the attach option. That's why I'm writing here data in express. If you not use the attach option, then you have to write here data equal to this. And if you write here attach this particular data, then no need to write here after calling the data. So if you run this, okay, it runs. And what is the summary? See, this is the summary. What is f value? It is less than this, 2 e to the power minus 16. That is, it is obviously less than 0.05. It's a very small number. It is less than 0.05. What is the rule? If p value is less than 0.05, we reject null hypothesis. That means means are not same. Means are different. Right? Up to this, it is okay?
Yes, sir.
Any question?
No, sir.
Sir, could you please repeat again about the data that we have to attach it or not?
If we write the attach command, do not write here data equal to this. If you don't use the attach command, then you have to write the name of the data set.
Okay.
Here. Suppose writing this the name of the data set is, suppose this is long name. So you can write this like this. Suppose we get and defining this. Dat is like this. And then attach that. Right? Now we move this. Run this. See the same output. Why? Because we're attaching here. If you don't attach, then we have to write then after this comma and data equal to name of the data set. This is a different path. You can use any one. And my suggestion is always use this attach option. Then you have to able to freely run your code.
Okay, sir.
Now the problem is here from ANOVA, it is clear that the all means are not same, but which one is different to other? That's why we use the Taki method. This is known as post hoc test. To test this is the difference between all groups. This is the lower bound and this is the adjusted p-value. And see this when in which case p-value is less than 0.05, in that case we reject the null. That means in case of CA there is a difference, in case of DA there is a difference, in case of E and A there is a difference. And clearly see the box plot. With respect to A, all three are different, clearly signified here. Similarly, you see with respect to B, C, D, E, with respect to B, C, D is different. Say F and C, with respect to C, F is different, clearly F is different. With respect to D and D, F is different. With D and D, F is different. So individually, which one is different, you can calculate with the help of this Taki test. This is the test using for multiple comparison of means, or what is in common literature it is termed as post hoc test. So in ANOVA, if we reject the null hypothesis, we have to perform the post hoc test to find out which group differs to which. It may happen mu1 equal to mu2, but mu1 not equal to mu3, and mu2 equal to mu3. So in that case, you have to find out for which particular category we are rejecting the null. So here, these are the case: CA, DA, EA, and then CB, DB, EB, FC, FD, and AP. In all these cases, there is a difference. But in case of BA, there is no difference. In case of FA, there is no difference. In case of FB, there is no difference. So you can make a group from this analysis. This A, B, and F is one category, and C, D, E is in another category. Right up to this, if you plot this, if you try to plot the ANOVA output, see, this is the residual versus fitted. This is the residual versus fitted line. Here, count spray group wise residual minus fitted. This is the normal QQ plot. And see, more or less it is normal. Some is outside these are the observations. It may be treated outlier, but more or less all the observations is coincide with the theoretical line. In ANOVA, we are not test the normality. How we test the normality? In case of ANOVA, with this residual plot, we infer about the normality of the data. Just like when you're talking about the regression in later on, you can see in regression also we can check the normality with the help of this residual plot. So in case of ANOVA, when there is more than two groups, Sharpia-Wilk or Komnogov test is not applicable. We test normality with the help of this normal QQ plot. Right? And currently I am skip this last two diagram. This is not in your syllabus. If you learn in if you go for an postgraduate level, then it is clear to all of you what is the leverage level and what is the scale and etc. So that's why I'm not right now. I'm skipping and see. I just run this code. You just see the output first. Then I will discuss the meaning of the code. What we done here, you just see B, C, D, E, F. 5 categories there. One category A is not there. Clear? One category is not there. And here C, D, and E is a significant predictor. Why? Because p-value is less than 0.05. Whereas B and F is not significant one with respect to A. Basically, this is the initial concept of dummy variable. I'm not going to detail on of this analysis. Basically, is ANOVA is nothing but a dummy variable regression model. So, what the result we got from ANOVA, that is more or less similar for dummy variable regression. For the time being, I am skipping this part. Later on, when you is your PG stage, you will know everything about this part. So I will just give you the code only, not the details of this analysis. And the code is summary.lm out. If we write this code, it gives you the dummy variable regression output. It can be shown mathematically how to fit this particular model. Clear? Up to this part, it is clear.
Yes,
Sir,
sir.
could you please repeat again Taki HSD?
This is the output. Code is visible. Taki HSD dot AOV dot output. That's the object name. And this is the interpretation between the each group is different or not. Mean for each group. So with respect to B and A, C and A and D. So for every group, mean difference is there. Significant means with respect to these two groups, the mean is different. And for p-value more than 0.5, more than 0.05 implied do not reject null. That means for group B and A, means are equal. But for C and A, we reject null. That means mu1 mean for C and mean for group A is different.
Okay,
Clear?
sir. Yeah.
And sir, please can you repeat the summary.lm part?
Pardon?
The last code which you have written, summary.lm part.
Summary.lm is the function and the object name is AV out.
Sorry, the what comes out of it, the table which is there in the console part, that is what I'm asking you to interpret.
Pardon?
Sir, the table which came out of this code, summary.lm.
This one, right?
Yes, sir. Yes, sir. Please,
I'm not
can
interpreting this. You just only see this is the significant variable. I'm not interpreting this. This is basically the dummy variable concept. Leave it now.
sir, but just you gave the introduction. Can you repeat that part?
If I give the introduction, it takes 1
No,
hour.
no, no. You gave the introduction already. So can you please repeat that part?
You
I'm
stated
not giving.
2-3 lines about it, so that
Yeah.
part, if you can just say it once more.
I am just talking about that. This is the dummy variable concept. And since A is not here, so A is the base. So with respect to A, the impact of these categories on count. So these three are significance. Have significant impact on count or whatever with a dependent variable. I think count. Yeah, count. But all other three, that is B and F, is not significantly impact on count. This is the impact. I will discuss on after regression.
Okay, sir.
So up to this part, any doubt?
No, sir.
No, sir.
No, sir.
No, sir.
Right. Fine, fine,
No, sir.
fine, fine. So it is visible.
Yes, sir.
Yes, sir.
Yes, sir.
You just write these two lines first.
Sir, X and Y টা capital তো?
যা খুশি, whatever you.
Okay, sir. Okay.
Done, sir.
Done, sir.
Done, sir.
Check the normality first. How we check this normality for these two variables? Two categories there. How we check this?
So Shapiro test.
Shapiro test, but this is a particular X for one group, Y for one group. How we check this?
Two-pair test, sir.
In case of pair test, we make the difference. But in case of independent test, how we check for these two? How we check these two? The thing is this, if you input your data like this, you can perform the t-test. Simply by t-test xy. No problem. This is the code, line 10.9. And by assuming variance equal is true. But if you input your data like this, in R, it is not possible to test Shapiro test. So in that case, you have to input data in such a way that all these dependent variables have in the same column and group variable in a different column. So how many observation? 1, 2, 3, 4, 5, 6, 7, 8, and another 8 is here. So you just if you try to follow the all possible assumptions, if you wish to check all possible assumptions, then what we have to done? We have to make the data frame like this, not like this. One is the X variable, all dependent, all observations in same variable, and another is the categorical variable, and or the group variable, and then make this as a group, right? So simply just open a Excel and write this all 8 values first, and then all these 8 values, and make corresponding these first 8 values as 1 and second 8 values as 2. Open
Sir,
a
I,
Excel.
sir, I have a question.
Yeah.
So, sir, here we individually have to check whether x and y follows a normal distribution or not.
You can check either X and Y, but you cannot check in this way the group wise.
That is, we cannot use the Shapiro test in this format.
So in this format, you have to use the only individually for X and individually for Y.
But sir, if we are to check the normality independently for x and y, why aren't we using the plot function and then checking for the normality curve, or say a box plot and then checking whether they are following the
This follow
normal
the process.
distribution?
This follow the process. When you write a paper, so you first give the QQ plot, then the Shapiro test, then it is looking good. Nothing else. You can directly use the Shapiro test. If you know the
Okay,
Shapiro test,
okay,
you can
okay.
use directly. But suppose in that case your paper length 2 page, but when you give a picture, it increases the size of the picture
Yes, sir, yes,
and little bit of decoration. So
yes,
one
sir.
thing you can clearly check for X Shapiro test only for X, Shapiro test only for Y. If both these series have normal, then it is okay for T test. Otherwise, you create a data frame, putting all these observation in one variable, and create another group variable, and then test the Shapiro test.
Yes. Sir, can you just repeat what to do in Excel? We can create the data frame in R itself.
You just create a variable named X and put all these observations. And for first 8, create another variable group, then first put 1 and then next put 2.
Okay, sir.
I'm just talking about this is the dependent variable, just deep. And here you write group. The group is 1. First 8 is 1. And next from 9 it is 2. Next 8 is a group variable and put the value of these values 512, 530, 498 here. Save it as a
Yes, sir,
giving
got
a
it.
name and import in R.
Okay, sir.
স্যার আরেকবার বলবেন এক্সেলটা একটু
Open Excel. First put all these values in one column and then make a group column. Put 1 for first these 8 values and 2 for these 8 values. Clear?
Done, sir.
Done. All of you.
Yes, sir.
Yes, sir.
So now run the codes of for t-test in R. Done this. All of you done this.
স্যার একটা কথা বলবো?
Yes. Please.
স্যার শুনতে পাচ্ছেন?
Yes, yes, please.
স্যার বলছি যে আমার না মানে বেশিরভাগ জায়গাটাতেই না কানেকশন চলে গেছিল, আমি মানে কিছু শুনতে পাইনি, মানে বারবার ডিসকানেক্ট হয়ে যাচ্ছিল।
It's a problem. I know. Which part you missed?
স্যার পুরোটাই মিস করেছি। ওই আপনি যখন বললেন যে ওই দুটো থাকলে পরে ওই এক্স আর ওয়াই, তারপর থেকে পুরোটাই স্যার এক্ষুনি কানেকশন এলো আবার স্যার, তাই জন্য পুরোটা।
With the help of this data, you just make a Excel sheet, putting these all observation in one column, and then make another column with up to for first this 8 observation 1 and next 8 observation 2.
Sir, for x one column and for y one column.
No. Putting x y is one column as dependent.
Sir, একটু দেখাবেন একবার?
Yeah, sure. So one column is for dependent and another is for group. Right?
Yes, sir.
Put one for first 8.
Okay.
And next 2 for another 8. Right? And put the all values here. Here. As you see this
Okay,
data,
okay, sir. I've got it.
just like this.
Yes, sir. Shamrat has sent in the message. I can see that.
Here,
Yes, sir. Yes, sir.
in this profile. So when you put this, then automatically you can run t-test.
Yes, sir. Yes, sir.
Sir, t-test we run only on the value, right?
Yeah, only on dependent variables.
Dependent variables, yes.
স্যার আমার এক্সেলটা একটু প্রবলেম করছে, আমি যদি লিব্রে অফিস দিয়ে করি আমি ওই জিনিসটা কোথায় পাবো? মানে ইম্পোর্ট ডেটা সেট করলে কিসের আন্ডারে ওটা আসবে স্যার?
Pardon, once again, import data set. Click here, import data set.
না স্যার, এক্সেলটা প্রবলেম করছে, খুললে হ্যাং হয়ে যাচ্ছে, ওই জন্য ওটাতে না করে লিব্রে অফিস থেকে আমি ওই ইয়েটা বানিয়েছি, সেটটা,
This is
ওই
the Excel
এর
sheet.
কলাম দিয়ে।
This is the Excel sheet. Extension is .xls, right?
বাট লিব্রে অফিসের থেকে করেছি তো স্যার, যখন ইনপুট করে ব্রাউজ করে ইনপুট করতে যাচ্ছি হচ্ছে না।
So you just make it save this file as CSV extension .csv.
ওকে স্যার, ওকে স্যার।
Sir, I'm having problem with the t-test code. It's showing some error.
It's showing some error.
I did.
I know why this error. Because you make the group variable as factor variable. Group equal to as factor group. Group equal to as factor group.
Sir, I didn't get that.
Sir, group equal to the factor group করে লিখো।
See the chat box. Group equal to as dot factor group. Make this group first. Then use t-test.
Sir, can you explain why do you need this?
Because if you directly import data from Excel, R recognize both the variables and numeric. See your structure, both the variables in numeric form. So t-test for why for t-test? To test the mean is the mean is different or same for two groups. So you have to define your group. When you make the factor, you define two groups.
Yes, sir. Sir, I have this error coming up, the same error I just shared in the chat box. Error in T, test value comparison 3 is possible only for atomic and list types.
You just share your screen, share your screen.
Yes, sir. Okay, so it is visible.
Yes.
So I run that and
No, not t-test value. T-test value tilde group.
the other variable is category. Yeah.
Yeah, the category. So not group is at factor group. Then category is as factor category.
Okay. Okay. guess it's the same error.
You just write names book too.
Names.
Names. Yeah. Value category. Okay. Yes. Okay. STR. Then STR. Yeah. And then make category s dot factor category. Run this. Yeah. Then t-test. You just use the tilde. Value tilde category.
Yeah, this sign, right? This sign only.
No, tilde sign. Just before the below the escape. Shift then press.
Yeah, I did that suddenly. Value and then this sign. You mean this, right? The curved one. The just
The
below.
card one.
Yeah, I just pressed that only.
Run this. Then run T. You
Sir,
just
is it taking place because he missed a hyphen after writing that less than sign before t-test?
Oh, yeah.
missing that. Thank you. This run T. Yeah.
Yeah, it's coming. It's coming.
The assignment operators. There is a mistake in assignment operator.
Yes, sir.
So you don't check the normality and homogeneity. You just take normality and homogeneity for your data.
Okay, sir. I'll do that. Thank you, sir. Sir, what will be the t-test code for the comparing the single? I mean, the ones we did in our SEM 3 syllabus. Like there was only one population. We have to one sample and one population. We have to compare the sample mean with the population mean. What should be the t-test code for that?
What should be the t-test score for that means?
Sir, like here we are
It is
dealing
one
with
sample t-test.
One sample t-test, the very basic students t-test. What is the code for that?
Like this. I'm sharing or not?
No, sir, you're not.
Just a minute. What is happening? I'm audible?
Yes, sir.
Yes, sir.
I will show you the comment only.
Okay, sir.
Can you share your screen?
Sir, mine?
Yeah.
Yes, sure. Yes. Sir, is it visible?
Yeah. What is your data name? Book 2.
Sorry, sir.
What is your data file name? Book 2. Recaps.
Yeah, book 2. Yeah.
What is the variable name? Value.
Variable name is value.
Yeah. What is the mean value? 502. And what is 519? Clear?
Yes, sir. So why isn't this working?
You just copy and paste paste the code in chat box.
Yes, sir.
Done this. Then T. X is null.
Sir, value my is okay, small v. Yeah. So,
You just make mu is small p. Small m. I'm writing capital small m. Yeah, we done this. Yeah, this is the result.
yes. Sir.
In case of t-test, the function is t-dot test. When you doing the independent date, you have to write with the help of tilde, dependent variable, tilde, categorical variable. When you write the pair t-test, when you going for the pair t-test, p post after before, then paired equal to true. One sample test, name the variable and the mean value, which value you have to test.
And what does it mu imply?
Mu is
the
the
mean. Mu is
mu
the mean.
mu. Here.
Yes, sir. Yes.
See the case. See the case. I think the case should be here. Just a minute. Yeah. You just stop sharing.
Yes.
একটা প্রশ্ন ছিল
প্লিজ ইয়া
বলছি যে এক্সেল থেকে ইম্পোর্ট করাটা তো শিখলাম বাট আমার ল্যাপটপে না মানে মাইক্রোসফট একটুখানি প্রবলেম করে তো ওটা আমি যদি লিব্রে থেকে করি তাহলে ওটা হচ্ছে বাট
you have to save in csv.csv then import
.csv
yeah
আচ্ছা
তাতেও হচ্ছে না
তাতেও হচ্ছে না
লিখে
just see this. I will show you the then part.
Okay.
See, for example, this is an example. A report published that India has a mean lifespan of around 70 years, where Kerala has the longest life expectancy of 74.9 years, whereas state of West Bengal has the mean lifespan of 70.2 years. Right? So a random sample of 20 collected to validate the information. So in that case, what is the null hypothesis? In this case, what is the null hypothesis?
Sir, can you repeat the question once?
This is given in the slide. You just read.
Yes, sir.
So the null hypothesis would be that the mean lifespan of people living in West Bengal is equal to the mean lifespan of people living in India all around.
It may be any other. If you write the null hypothesis like this, so your test procedure will definitely change. What is your population? What is the population value here?
So the mean values are given.
Sir, it would be equal to India has mean lifespan of around 70 years. So if it is equal to 70 or less, alternative is less than or greater than or not equal to 70.
So, sir,
That's
the null hypothesis will be okay. We have two means. So, mm, if mu1 and mu2 are the means of,
So it here it can be possible. You can form three null hypotheses. One is out of these 20 sample, one can test mu equal to 70, mu not equal to 70, or mu more than 70. One can
yes,
test mu equal to 74.9 or mu not greater than equal to 74.9. That is West Bengal is life expectancy in West Bengal is higher than Kerala, or life expectancy in West Bengal is higher than India. Or one can check, is the life expectancy in West Bengal reported in the report that is 70.2 is true. That is, it is mu equal to 70.2 or mu greater than 70.2. So you can form anyone, right? You can form anyone from this. And this is the example of one sample t-test. So when you get the 20 observations, then what is your mu value? If you put mu equal to 70, it tests mu equal to 70 against the alternative mu not equal to 70. If you test mu equal to 74.9, it's check the null hypothesis mu equal to 74.9. If it checks 70.2, then it gives you the null hypothesis mu equal to 70.2 against the alternative mu not equal to 70.2. Clear?
yes.
Yes,
After the end of this class, I will give you the data set. So you
yes,
just
sir.
try to do your own.
Sir, can we even check that the mean of Kerala and mean of Bengal are equal? But that will not be a problem of single sample then.
That will be not a problem of single sample. Then you have to collect the another sample from Kerala, and that is the independent t-test.
Yes, sir. Yes, sir. So here we compare with 70 only. We check the null hypothesis to be 70 against alternative. It is
Against
not
alternative,
70.
or you can check with respect to Kerala. Even you can check with respect to Indian data, data from data of West Bengal.
Yes, sir. Fine. Sir.
Right?
Yes, sir.
It is okay?
Yes, sir.
Now just I am sending a code. You just copy and paste in your R code. The last one for today. You just copy and paste. Then I will discuss.
Yes, sir. Done.
The first three lines actually three vectors. Type 1 score, type 2 score, and type 3 score. These are the different score obtained by the individuals in different type of examination. One is online open book, one is online opening camera, and one is offline examination. So these are the marks. So is the average marks is same or not? This is the question. Since there is more than two population, we are going for ANOVA. So first we put this value, type 1, type 2, type 3. Then this is the, we make a score vector. What is score? Score is type 1 score, type 2 score, and type 3 score. What are the type? Types are type 1, type 2, type 3. And what are the time? Times is length type 1 score, length type 2 score, and length type 3 scores. This is the code. First we define score, type 1, type 2, type 3. Then we define the type. And type is a repetition of type 1, type 2, and type 3. And times is basically the combination of length of the particular scores. It may be same, it may be different. So if we run this type, then we make this a data frame with respect to type and score. So with this, we make a data frame. See, this is the data. If you view data, Where is the data? It's hanging. Where is data? Yeah, it's opening. Just see, this is the data. So, this is the code by which you can directly make your data like this. This is type 1, this is type 2, this is type 3, all are, yeah, 27 observation. You just see, here 27 observation is there. In the previous case, I told you open a Excel and create, just input your data and import. So if you wish to do in R, you just run this type of codes. Automatically you make your data like this. So this is your home task for the previous one case. You just write X and Y, then make this like a group. Just like this. Clear? I think it is clear. And now it is very easy to find the ANOVA result and then result. This is the result for ANOVA.
Sir, can you please show the table again?
Write a summary result. This is the summary value. Here, this is the table. See, in the previous case, you make it in Excel, but you can also form this type of table using these two lines. First, put your data, then name the data in a particular just value, cat, whatever be the name, and then type or the category or group. This is the group. So automatically you make this data frame. So try to do your own. The code is given to you, and I am explaining the entire thing. So it is your home task to make this. So tomorrow is your off day, practice day. You practice entire thing. Data is given to you. I will also provide some assignment so that you can practice, and we will meet again on Sunday. On that day, I will discuss the optimization tools and regression.
Okay, sir.
Thank you, sir.
Okay,
Sir, that LibreOffice problem.
There is no LibreOffice problem. You just put data here, like these two type of code, and make your data like it using data.frame function. So
Okay,
don't
sir.
use Excel.
Okay, sir.
Clear?
Yes, sir. Yes, sir.